In this video, we're going to learn about interference and also diffraction patterns. So for interference is mostly for the Young's double slit. Diffraction pattern is for single slit and also multiple slit. The reason why I put them side by side because the three of them have patterns, but only for double slit yang what we call interference. Alright, here we have apparatus and other names and also pattern and the pattern description. I put it here. So sometimes you'll read it in the question that it's talking about Young's double slit. They are the same with double slit experiment. For the single slit, sometimes they refer it as a hole or an opening. That means this is a single slit. And if the question is giving you a diffraction grating, so it is actually a multiple slit. Before we go to the pattern, I need to introduce you with some of the terms that I'll be using to explain these patterns. The first terms that I'll be using is bright fringe. Bright fringe means like literally bright. You can see the pattern is bright, and dark fringe is for dark area. Like for example, this is considered as bright fringe, while this one is considered as dark fringe. We also have central bright, which is literally means it is at the center of the pattern. And sometimes you also hear maximum or maxima. They are equivalent to bright fringe. A minimum or minima equivalent to dark fringe, and central maximum is equivalent to central bright. Then we also see the term prominent. Prominent means very strong. We also will see the term width ialah kelebaran. Here, for example, we have very wide central maxima. We also have order. So sometimes we have 0th order, sometimes we have first order. It depends on the pattern. For example, for diffraction grating, we mostly can only observe maxima. We don't really have minima per se because we don't have dark fringes. It's mostly just dots or slices of maxima. Let's go to the double slit experiment. Here we can see the pattern. They are quite uniform. The width of the dark fringes are almost the same. And then for the bright fringe, they are also the same. Then we have central bright. The order for the central bright is 0. The order for the first dark is also 0. But the first bright is first order. So sometimes in the question, they give you like this. First bright fringe means that the order is 1. But if they say first dark fringe, the order is 0 because it is the first dark that you will observe. But if the question give you first order dark fringe, literally the first order of that dark fringe. So here it is. This is the first dark fringe, but this is the first order dark fringe. For single slit pattern, they have the widest central maximum. So this what we call width. This width can be measured based on the first order minima. So once you got the distance between the central of the width to the first minima, then you kali je 2, you dah dapat the width. Now the prominent fringes are the minima. So you can see this, we have the brightest width, but then the prominent ones are the minima. It gets wider as the order increases. And then you will see also that the maxima getting dimmer and dimmer as the order increases. So most of the time, we only focus on the width and the first order, or maybe sometimes on the second order, and that's all. Now let's go to the last one, which is the multiple slit. The prominent fringes are maxima. We don't really observe the minima per se because the lights are so strong. We don't really much care about the minima per se. So the first maximum is the 0th order. So this is basically the central maxima. The maxima separation increases as the order increases. So you can see here, this is the distance between the two maxima, and this one, as the order gets increases, dia punya lebar tu, dia punya jarak tu makin jarak, tapi the width of the maxima is still the same. Now let's go to the technicality part of double slit experiment. So the distance between the two slits, because it is a double slit, obviously we only have two slits. So the distance between the two slits is called small d. The distance between the slits to the screen that we can observe is called capital D. The CB is the central bright. This is where you can observe the maxima, the brightest. So if let's say I want to know what is the distance between the central bright to the third order bright fringe, it is actually Y3B. B stands for bright, obviously. So if I want to get the distance from the center bright to the second order dark fringe, I'm going to call it Y2D. So remember, this is a zeroth order, even though this is the first dark fringe. So first, second, third dark fringe, the order is 2. So do not get confused. These are just examples. Next, we have delta Y. Delta Y is so amazing because of the nature of a Young's double slit pattern. They are uniform. You can see that delta Y is the distance between two consecutive, maksudnya berjiran, two consecutive bright fringe. This one, if first order to the second order, this distance is actually the same if you measure daripada dark fringe to the consecutive dark fringe. So ini pun delta Y dia ni sama je dengan delta Y dekat sini. It doesn't matter. Kalau bright dengan sebelah jiran dia bright, this is your delta Y. Kalau you ambil dark dengan jiran sebelahnya dark, this is also delta Y. And the last one is the angle. If you want to get the angle for the third order bright fringe, then you can measure daripada center of the central bright. Tahu center, this is our central bright. The center of the central bright ke third order tu, then you're going to call this one is theta 3. And if you let's say nak ambil daripada center kepada second dark fringe, not second dark fringe, second order dark fringe, then it is called theta 2. Mesti start daripada center of the central bright. Alright, so instead of me going to the technicality of these two patterns, I'm just gonna straight away go to the equations for the double slit experiment. So we have bright fringe order. So this is the equation. YM, M as in the order what the question is gonna ask you, equals to M lambda D over D. For the dark fringe order, YM equals to M plus half times lambda D over D. Why is it plus half? Because it's coming from two in-phase coherent sources, and that's why if you want to get the dark, you have to add in half. Fringe spacing, which is the delta Y, equals to lambda D over D. Notice that we don't have any more order because whatever the sequence is, it is the next consecutive bright fringe or dark fringe. Now I want to show you the difference between wavelength variation. We know that red color has longer wavelength and blue or violet has the smallest wavelength. So if you have red color, the width of the fringes is wider to compare with blue. So red is the longest, violet is the shortest, longer lambda, bigger fringe separation. Let's go to the technicality of single slit pattern. A as in the aperture or the opening of the single slit, and the distance between the opening to the screen to observe this pattern is called capital D. So let's go to the mth minima. Ym equals to m lambda d over A. And then in order for us to get the width of the central maximum, W equals to 2y1. You can see that 2y1 is actually this equation. Y1 equals to 1 lambda d over A. And you can see 2 coming from this 2. This is actually 1 lambda d over A. Can you see that? So sometimes they can ask you about the maxima. Then you just add half into the equation. For the minimum, you can also get A equals to sine theta. This equation, if the question is asking for the theta lah, theta 1 from the central of the central maxima to the first minima. For theta 2, it's coming from the center of the central maxima to the second order dark fringe. And next we go to the pattern of different wavelength. Again, as I say, red has the longest wavelength and violet has the shortest wavelength. So for red, it has the widest width, and then we have green in the middle and the shortest coming from violet. So again, longer lambda, smaller width smaller. There you go. Now let's go to the technicality of diffraction grating. We have 0th order, 1st order, 2nd order. They goes for both sides, whether it is up and down or left and right. They are all the same in terms of the order. Then we have the theta 1, just the same as the single slit. Theta 2, it's coming from the central bright to the central maxima, to the 2nd order maxima, and so on. Next we have special case. Let me zoom in this part to here. We have diffraction gratings, basically multiple slit grating. So we have like hundreds up to 1,000 up to 2,000 slits that is compressed into one small length, like maybe in 1 millimeters or up to 1 centimeters. So you have like 500 or 600 slits in 1 centimeter. So we have here D. D is the spacing, the slit, and we call it as grating spacing, equals to L over N. N is the number of slits. Just now, like I said, 600, 500, those are the numbers. L is the length, like I said just now, like 1 centimeter, and so on. If you want to get the angle, you just use D sine theta, M, which is that order, equals to M lambda. Next we have a number of maximum order. Because the order at the top is the same as the order at the bottom, you can get the order, number of maximum order, like this one, 2. The order, the maximum order that you can observe with your eyes are just 2. That's it. But if the question is asking for what is the number of maxima appeared on the screen, then you kena darab 2 lah. Darab 2 dan tambah 1. Kenapa cerita je macam tu? Let's see, for this example, we can only observe up to 2 orders. So you got 2 at the top, 2 at the bottom, and then you add one more order, which is the 0th order, which is the central maxima. Here we have longer lambda, bigger maxima separation. So you can see this, it separates longer and wider to compare with violet. But in terms of the maxima itself, they are the same.